Hello and welcome to 5 Minutes of Postgres. My name is Lucas and today we're going to talk about zero-downtime Postgres upgrades and how to logically replicate very large tables. First of all, we'll start with this blog post by Brent Anderson on the Knock blog. Knock provides a product where they want to make sure that they have as little downtime as possible. They saw themselves face a Postgres major version upgrade from Postgres 11, which is now end of life, to Postgres 15, which is the second most recent Postgres release. Now they wanted to have zero downtime and to use logical replication to achieve this. For additional context, they're using a managed service provider, AWS Aurora, but until recently Aurora did not have any mechanism to support what they now call blue-green upgrades, which is a way to use logical replication for upgrades. So you essentially had to do it manually. Now, first of all, there is a way to do upgrades without using logical replication, which is to just do what's called an in-place upgrade. So this is running the pg upgrade command, which either your provider runs for you when you modify the Postgres version, or if you're on a self-managed system, you can just run pg upgrade. PG upgrades is usually very fast, it's usually just a few minutes. There are sometimes edge cases, but generally speaking, PG upgrade is the easiest way to do major version upgrades. But if you're trying to keep downtime to a minimum because you absolutely cannot afford even a minute of downtime, then you need to be creative and find other solutions. You can have logical replication across different database versions. And so the general idea here is we bring up a new database on a new Postgres version, we copy over all the tables, then set up a publication on the old database, a logical replication subscription on the new database, and then you're logically replicating tables to that new database. Then when you're confident that everything looks good and you're following that old database, you can then point your application to a new database. So really what logical replication allows us to do is have these two different versions running side by side. Now, this is the approach that they've used here, but there were a couple of caveats that they ran into. I would say the most important thing that they did is they essentially went table by table, because the problem that they saw is if they were to replicate too many tables at once, the initial synchronization of the table data would take too long. The copy that logical replication does by default takes too long. And then they saw issues like transaction wraparound on the old primary because it had to retain all that transaction information whilst the initial data copy was happening. That's a fundamental way of how logical replication works, by the way, so you have to have that data copied whilst keeping open the replication slot. What they ended up doing is essentially copying these tables table by table and being a bit creative of how to achieve it. And then ultimately, after a couple of checks, they cut over to a new database. Now in HackerNews, there were quite a few comments on this approach, and really they were all revolving around, this is very IO heavy if you're copying the tables like they were doing, and that doesn't really work if you have very large tables. And so there are alternate approaches specifically for very large tables. And there's two I want to talk about specifically. So first of all, in the context of RDS, there's an approach that Instacart has developed. And earlier this year, they talked about zero-downtime Postgres cutovers. Fortunately, the tooling that they referenced here does not seem to be publicly available yet. And so a better reference is actually their older blog post, where they talk a little bit more about what they're doing underneath the hood. And so ultimately, what they describe in that blog post is that they're creating a replication slot on the primary, then they're snapshotting the old primary, and then they're restoring a snapshot, and then they're advancing the replication slot. We'll take a look at that in a moment. Now, there are some concerns that people have had over the years that there are certain edge cases, specifically around transactions that are in flight when you're doing that disk snapshot, that may cause issues. Now, in the same HackerNews thread, Nikolay from PostgreSQL also commented, and he worked with the GitLab team on doing their upgrades on their self-managed servers. And this approach here is a bit different. What Nikolay describes here is an approach that you could, for example, run when you're running on Patroni. And so the idea is you make a copy of your existing cluster, you have that follow the old cluster using physical replication. You're then stopping the new cluster. You're creating a logical replication slot on the current primary. And then you're using recovery target LSN to catch up your physical replica to the specific LSN of the logical slot. And then you start logically replicating. Recovery target LSN, just for context, is essentially a way for a stop replica to be configured so that it will keep replaying until a particular logical sequence number, a particular position in the Postgres wall stream, and then it will stop and essentially shut down again. So you can use that, for example, in point-in-time recovery if you want to get to a very specific point. And so this is great. It's much more precise than the approach that Instacart is describing, but you could only use that on your own server. I wanted to quickly illustrate this also because it is a bit hard to understand. And so the different approaches are, On managed service providers, usually you don't have control over primitives such as recovery target LSN. And so the approach that Instacart is describing is you're creating that logical replication slot first, you then making a disk snapshot, then you look at which LSN did that disk snapshot take the snapshot off, and then you're advancing your logical replication slot to that point. Then you can do your upgrade, and then you're logically replicating based on that disk snapshot. That lets you avoid all the table copy. It has the benefit of supporting very large tables easily, but there's a bit of a risk here of relying on the exact semantics of a disk snapshot. And so the self-managed approach that Nikolay is describing is much safer, I would argue, but you can of course only run this if you're running Postgres yourself, which is you create a physical replica, for example, of PG-based backup, then you're physically replicating, just regular wall replication, and then you're stopping that replica. Then you create the logical replication slot on the old primary. You note which LSN number that was created with, because you don't have a subscriber yet, right? It's not going to advance. And then you have your replica catch up to the starting point of the logical slot. At that point, you can do the upgrade, and then you create the subscription and have it follow the logical replication stream. That seems like the much better way of solving this problem. And so what I really wish is that providers implemented this second approach for us so that we could just reliably use it without having to come up with our own solution. Now, on that last note, RDS has actually implemented what they call blue-green deployments, but it does seem like that's not necessarily something that I would trust 100% yet. I personally haven't used them much, but here on HackerNews, somebody commented that they recently tried it and ultimately things got stalled and the AWS UI essentially said, hey, I couldn't switch over. And so I think this is the kind of thing where sometimes the managed service providers don't give you enough introspection, enough access to really perform this well. But I hope that we'll see AWS iterate on this further and other providers like Azure or GCP offer a better way to do major version upgrades as well. Thank you so much for listening. This was 5 Minutes of Postgres. Subscribe to our YouTube channel to hear about next week's episode, and talk to you next week.